Good morning. My name is Mr. Ross, and welcome to Science with Mr. Ross. This morning we have with us
Jahira.
Jason. Darlene.
Darlene. All right, what we're going to do is, in the class, you did some experiments on density, right? And one of them was you took and you poured different liquids in here, and down on the bottom we had some clear liquid, and we had some really dark red, some light red, and on the top we had some sort of light yellowish colored liquid. Why are they separated like that? Does anybody want to tell me?
Because of their densities.
Because there are densities, right? And the one on the bottom would
Had the most density.
have most density. The one on the top would,
Had less density.
and the one right below it would have
It was in the middle.
a little more density, and the one down here a little more density. Now, up in the very, very top, there is a piece of something floating in there. What was that?
A piece of wax.
A piece of wax. Why is it floating up on the top?
Because it had less density than the two.
Than the
And the liquid.
than the liquid, right?
Yeah.
Less density in the wet liquid. This one down here, this piece of brass that we have, is down where?
At the bottom.
Down at the bottom. And why is it all the way down at the bottom?
It had a large amount of density.
A large amount of density. So what you're telling me is the least dense ones
Floated.
are floated,
Yes.
right? And the more dense
Sank.
sank. And over here, this one is, we can't see the layers of the liquid quite as well, but down here is one layer, like yellow. Here's another layer. Here's some wax right on top of it. And at the very top, there's the cork right up there, floating right up on top, right? So what is this thing down here? That's a stopper, right?
Yeah.
That's a rubber stopper. So why is it down in this area?
Because the density was like in the middle.
Because the density is like in the middle, so it sank. And the cork floating
It
on
had a less density.
had
So
less density. So in the summertime, we all know about this, right? Because in August, when it's nice and hot, you go over here to the pool, you jump in the water, and you lay back.
You
What
float.
happens? You float. Why?
Because your body has less dense in water.
Your body has less density than the water. Gravity's trying to make you fall down in the water, right?
Yeah.
Right. So if gravity is pushing you down, what's holding you up? Anybody want to take a guess? There must be something pushing you back up, right? Okay, I'll give you the answer. It's something called buoyant force. Right there. You had it on the paper. You could have read it. Right, buoyant force is what's pushing you up, right? Gravity's trying to pull you down. This buoyant force is pushing you up. Right, if we take these balloons over here, let's take one of these balloons, right? And I'm holding it now, right? What is it's filled with helium, right? Is it less or more dense than air?
Less.
Less dense than air. How do you know that?
Because it's floats.
Because when I let go of it,
It floats.
it floats up, right? So, and the reason it floats up is because of something called buoyant force. And what I have some very scientific instruments, right? What is this?
A bottle.
Bottle, old plastic soda bottle, right?
Yes.
And this is just plain old water. And I'm going to pour some water in this plastic soda bottle. About that much, so we don't make too much of a mess. All right, and I have a plastic egg, and on the inside of the plastic egg, I have it weighted down with some clay, right? And I have a little string fastened to it, right? And I have this, what is this?
The spring.
Spring scale, right? What is it used for?
To see how much it weighs.
See how much it weighs. Okay, so what I want you to do is carefully hook it up there and weigh that.
200 grams.
200 grams, right? Take your hand, hold underneath, push up on it a little bit. What happens?
It goes back up.
It goes back up. So what is happening really whenever you're weighing this? What's causing it to come down?
The buoyancy.
No, what's pulling it down?
Gravity.
Gravity is pulling it down, right? Okay, and in your hand, as you're counteracting the gravity, and you're pushing it up, so the reading we get is much less. What would happen, do you think, if I take this, 200 grams, and I lower this down in the water?
Oh,
Just
float?
like you're getting into the bathtub. You think it's going to float?
Oh no, I'll sink.
Why do you think it's going to sink?
Because it's heavy.
Because it's heavy and its density is
Probably
more than the water, right?
Yeah.
But what do you think is going to happen to the weight? Okay, I'm going to let you do it. Lower it down in there. Don't touch the sides. Just lower it down very carefully. Move your fingers up so that you can read.
It goes back up
Goes back up. What's it weigh now?
50 grams.
Go all the way down. What's it weigh?
0 grams.
Oh, you're on the bottom. Don't touch the bottom. Up a little bit. What's it weigh right there?
Like 10.
Like 10 grams? So it went from 200 to 10, right? Same as if we were to take and put our hand underneath it and
Yep.
push it up. What caused that to happen?
The
Now you can say it.
buoyant.
Buoyant force,
Force.
all right? The buoyant force, that fluid, the liquid water, all right, is exerting a force which is really pushing up on it. It's a buoyant force, just like the buoyant force up there. Now, if we were to take this out, all right, and put just a little bit of weight in it, see if we can get it to float. What do you think happened to the density of it? No.
It's less.
It's less. Why? Because there's not as much clay in, so this whole thing is less dense. Right?
Right now it's on 50 grams.
50 grams. Lower it in there very carefully.
It
Oh.
floating. It floats.
Okay,
now.
what happened to the weight?
It's less.
Less. It's like there's 50 grams of force pushing up on this, making
Yeah.
it go to 0. And what is that force called?
Buoyant
Buoyant force, right. There's a force. It's the same rate. You take this big old battleship or big old cargo ship, the tankers that are coming into Boston Harbor, right? How much? They weigh a lot, right? They're big. They weigh lots and lots and lots of tons. But with the way they're constructed, they're less dense than the water. So what are they going to do?
They're gonna sink.
Less
gonna
dense
float.
than the water?
Oh, they're gonna float.
They're going to float, right? Right, that's what causes them to float. And we bring in one of those oil tankers and we pump all the oil out of it. What happens to its overall density? We take out, like, what happened to the density of this when we took the clay out?
Oh, it's less.
Less. So we take this big old oil tanker that weighs tons and tons and tons, and we pump the oil out of it. It becomes less dense, right? When it was full of oil, it went down into the water. It still was floating, but it went way down in the water. When we take the oil out, what happens to it?
It floats again.
It's going to come back up again, right? It's going to float a little bit higher. Okay, now, so if we were to take and subtract the weights we had there, we could come up with the buoyant force. What do you think the buoyant force is going to be for that balloon? How much force do you think it's going to push up? Do you think we can find out?
Probably.
Okay, probably? All right, let's see if we can find out. You want to weigh this? Let's weigh this. Lump of clay. Back up one. No, leave that one there. Leave that one. That has to stay on 0. Line this up. Let me help you just a minute.
So it's
All right, what is this weigh now?
88 grams.
88 grams?
Yep.
Would you want to write that down for a moment? Now, how am I going to figure out what the force is here? When we had this, and what happened when we pushed up on this?
It went up.
It went up a little bit, right? In other words, the amount it was measuring was less. So what if instead of me picking up on that, if I take this balloon, right, and let it try to lift that 88 grams, what do you think is going to happen? Is it going to be able to pick it up?
No.
What is it going to do?
It's gonna stay the same.
You think it's going to stay the same? What's your scale reading?
It went down.
It went down. Hold it. All right. Why did it go down?
Because there was more more weight added.
More weight added or less weight?
Less weight, less.
Okay, well, what is really happening, okay, we had the clay on there, and the reason it weighs what it does is because what? Gravity is
Pushing down.
pushing down, right? So that force, gravity force is pulling it down. Now then this balloon, which has a buoyant force, and we tied it to it, and it's trying to push it up, right? So the two forces are going to subtract a little bit, right? And the difference is the buoyant force. So now then let's measure it. So leave that one there. Just move the small one. This one. Wrong way. Want to go less? Keep going.
So it's 84.
84. And what did we have before? We had 88 or 84. And what we want to do is take the difference, which is what? 4 grams?
Yep.
Yeah.
So there's 4 grams of force pulling up. What do you think if we took this other balloon over here, which is looking pretty bad shape? You want to bring me that one? All right. And we also let it pull up. What do you think is going to happen?
I think it's gonna be the same.
You think it's going to be the same?
Yeah.
What do you think?
Same.
You think it's the same? How about you?
Yeah. I think it's gonna be the same.
All right. Well, that's okay. Let's just think about it a minute. This one's pulling up with a buoyant force of 4 grams, right? This one's going to be pull up with what?
I think 4 grams too.
Well, I don't know whether it's going to be 4 or not, but it's going to be. It's pulling up with some.
Yeah.
We don't know what it is right now, right? So let's just add it.
Oh.
Now what happened?
It went down.
Went down.
It went down.
What?
What is it now?
Now it's 83.
83. Right, so 88, and we subtract 83 from it. And we get
Oh, 5.
0.5 or 5?
5 grams.
It's down 5. So there's one more, right? This balloon here had, because it's all blown up, right? And its buoyant force was 4 grams. This one has a buoyant force of
3.
1 gram,
Oh yeah, 1.
right? So our total force up now is 5 grams, right? This one pulls up with 4, this one pulls up with 1, and it's 5 grams buoyant force. If we added another balloon, if we added another one exactly like this, right? Had 4 grams of force, and I put it on there, what would our reading be?
6.
We take 4,
8
4,
grams.
8, right? It'd be 8 grams. And so we have 8 grams of buoyant force pulling up. All right, you must have a question.
No.
No?
No.
No question? No? So when you go out somewhere in the pool and you jump in the water and you float, what's keeping you up?
The,
Go
I want to say
Yeah, you do. Go ahead.
The buoyant.
The buoyant force,
Force.
right? And if you weigh 120 pounds, or 220 like I do, right, and you jump into water, how much force do you think's making me float? How much buoyant force would it be? I'm floating right up on top of the water. Gravity's trying to pull down 220 pounds, right? This buoyant, and I'm just sort of laying still, this buoyant force would be pushing me up, right? So it'd be a buoyant force of 220 pounds because I'm just sort of standing still. Now, let's take, how much force did we say this balloon had?
4.
4 grams.
4 grams.
All right. Let's take and let's get 4 grams of clay. Is that about 4 grams?
Yeah.
All right. It's 4 grams of clay. Let's see if this works. We'll put 4 grams of clay on this balloon. What do you think is going to happen?
It's gonna
I think it's
come-
gonna.
go. Gonna go up. Oh, it's gonna come down.
All right, we got a little too much. Let's take just a little bit off. All right, we get just the right amount on it. What happens to it?
It's going up.
Well, it's going up very slowly though, right? And if I get just the right amount of weight on this to balance the force, right, then it'll just sort of sit there and float. It's not going all the way to the, all the way.
It's like if you're in the water.
It's like if
Floating.
if you were a diver and we
Yeah.
put weights on you to sort of balance out the buoyant force, right, you could sort of float along. You'd be almost like being weightless. In fact, the astronauts, right, one of their training things, it's hard for them to become weightless here on Earth because of the gravity, right? And what they do is they put some weights on them, throw it in a big tub of water, and the guys down there and the girls, right, are just sort of floating around. It's like they're weightless. They're not really weightless, but this gives them basically the same effect so they can do some of their training that way. So it's just sort of floating along there. Now, as the balloon loses the gas,
No.
if it does, like this one,
Oh,
right, what's going to happen to the buoyant force?
it's gonna go down.
It's going to go down, right? And that what would happen with that weight that we have on there now? What was going to happen to the balloon?
It's gonna go.
It's going to go down. What we did is we took a look at the density, right? And we found out that density, right, the more dense it is in this column, right, the more dense the fluid, what is on the bottom, right? Then the
Less dense floats.
less dense is up on the top, right? And even the solid things that we have, right, the less dense ones will float up on top, and the more dense will float down the bottom. Like this rubber stopper is floating on top of whatever it is here because it's less dense than this fluid here. The cork is way up on the top, which is less dense than the top fluid, and the wax, right, is floating right on top of this green one, right, because it's less dense than the green, but it's more dense than the fluid up on top. Right? The same thing is true. We don't have to have the liquids, right? Air is really a fluid, right? And it also causes buoyancy. So if you were to weigh me right now on the scale, I would weigh just a little bit less than what I really weigh because, well, guess what? I'm standing here in the air, right? And I'm displacing the air, and there's a buoyant force pushing me up a little bit, right? So when you weigh me, I weigh just a tiny bit less than what I really do because of what? The buoyant force pushing me up. So, do you think you can do this experiment by yourself now? You need all these scientific instruments like plastic bottle, right? Some clay you can steal from your little brothers and sisters, and you can go home and show them your magic, and you can make a balloon just sort of float there and there. Thank you for watching. I'm Mr. Ross. We hope you learned something about buoyant forces and gravity, and hope to see you the next time.